Hello everybody, and welcome back to the channel. This is Michael, KE4EST, and today we are going to look at this Eico 315, I believe. I don't see it specifically right on the face of it. Why am I missing that? I think this is 315. And you can see I've got it zoomed way back here. This is kind of a tall unit. Let's see if I can find a tape measure here. So, I mean, you can see there that's a little less than 13 inches high and just about 12 inches across. Now it's kind of, it's like what, a little over 5 inches. It's not very deep, so it can stick on something, you got the big display here and the big everything, and that makes it nice, back then, before the digital displays and all that stuff. Some of these are smaller, kind of like the one I've got back behind there. Well, you can't see it, but the one the IG42, the Heathkit one. It's kind of small, and it's kind of hard to get in on frequency. Now, some of these you can line up a little bit better so you can really dial it in. And this one here's got a lot more gearing to it. It takes a while to get across so I can really zero in on something a little bit easier than, say, the Heathkit in the background back there. But yeah, this takes up quite a bit of real estate on your bench, but I mean, if that's what you're doing, you're set for that, it doesn't matter. And back then you'd want something like this. This particular unit came out in 1951. I was joking about it being 315. I know it's a 315, but I thought you could see it somewhere here, but maybe not. I see Eico. Tells where it's made in Brooklyn, New York, and all that, but first thing about this one is somebody has had this one. It's had a little bit of a rough life, I guess, when it got retired or whatever. There is, I'll zoom in here in a minute, but I'm touching the actual thing if I'm careful, so I can touch the needle there. The glass is busted out of it. And the reason I know it got broke out of it, this has been stuck somewhere. Something's got shoved up against it and busted it, because I was zooming in. There's a crack here, there's a crack here in this. I think there's a crack over here. There's a crack kind of behind the knob here. In this bezel here, it's kind of it's kind of rough. And then when I was looking down in here, I noticed that there's a piece of glass or two down in there. But the good thing is the little clips are still in here. You can't see them, of course, in the camera. They're back in here. Get a new piece of glass and put in it, or plexiglass or whatever. I think I'm going to see if I can find a piece of glass and put in this one. That's what I would like to do. So we'll see how that goes. I got a local glass place where, of course, you can get online. There's a lot of reasonable places to get glass cut. Some of them ain't so reasonable. You got to watch that, but anyway, so this goes from 75 kilocycles or kilohertz all the way up to 50 megahertz, just straight up. It can tune that, and then with the circuitry in it, it'll tune from 75 to 50 megahertz, 75 kilohertz all the way up. Different bands. There's from band A through F here, will go up to 50 megahertz. And then it'll go from, I think it's 40 maybe, something like that. It shows 45 right there, and there's 40. Maybe it'll go up below 40 megahertz all the way up to 150 megahertz on harmonics. And this one too has got like a nice little, inside here you can zero in more too. Like if you get everything lined up properly and you're on, let's go up here 10 megacycles and see what it's doing. So that's on 10 megacycles. Well, it's on 50. Let's go on around to 11. See, we come around here to, we're almost at 11.5, and we're back to 0 again. So maybe I can adjust that to put, I don't know, maybe that's just the way it is. It may work better on the lower bands. So I come all the way down there. Well, it's almost at 0. I don't know how you can see that right now, but and this here's hard to turn. I think this here's bent when it got mashed in or whatever happened to it. And you got your RF output here. Here's your multiplier. And I mean, everything's moving. This here's a little stiff. Everything could use, I'm sure, a lot of cleaning. On and off switch, band switch, and it's working. You can see, maybe you can see, I don't know. Let's go ahead and zoom in a little bit and move this. Whoops, sorry about that jerk there. If you look here, A, B, C, D, E, F, and G is on the same thing. So you'll have to, you know, if you got your output too high, it's going to jump and you start picking up harmonics, and you lower your output down maybe and attenuate it down some, and you can get back on the, you know, the F here. So this will, you know, use the harmonics for this band off of this band to go up to 150 megahertz. And then here, this here's a little wobbly here, needs a little probably tightened up or worked on there. There's supposed to be modulation, but it's going past it. It's wiggly, so I'm not feeling a click. And there's a click. Now this should be audio. We're over here pointing this way. So this is a little bit loose or something in there. But this will be for your 400 hertz tone. If you put it all the way over to audio. In the middle is just RF only. And then you can have modulation, where you can feed in external modulation, you know, whatever you want to feed into it. So let's see, where do I want to set this camera? How do I want to this thing is just so big. What I'm going to do is we're going to just make a whole video here, just taking this thing apart and looking at it and all that stuff. There's 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. There's 12 screws on the face of it to take it apart. And on the back, there's 2 screws here. So I'll go ahead and take these 2 screws out. And it looks to be all these screws are the same, but when you're doing something like this, you kind of want to make you something over, you know, like use your little tray or something. Like sometimes these here is real handy. This has got these like little bent wires in it. I've had this for years. I just kind of make my own wires now, but if I'm experimenting something on a breadboard, I'll use, you know, kind of make my own. But this here I just happen to be laying over there. This here you can open it up, put your screws in different sections or whatever. But these are all pretty much the same. But sometimes there'll be different screws, different sizes, different lengths. So you want to do that. Here's, looks like it's got the original line cord on it, and of course somebody's wrapped it up and put the rubber band around it. I don't know if I much like that, because they, over years of being set like this here will start to crack and stuff. But line cords ain't that expensive. You know, you can just replace these. They're pretty bad. Like I said, that next year this thing will be 70 years old. So let's swing it back around here carefully. I gotta be careful because I don't want to stick my hand here and bend that needle. But I will try to go and get these screws out here. I'll start with these bottom screws, so I can hopefully control it better when if it just falls out. You know, some of these things you take these out like this, and some people say it's a good idea to lay it on its back and take it out. Maybe it is. I'm trying to do this on camera, and I don't have an overhead camera set up, so I'm going to work my way up from the bottom. What I'm going to do, so I can so we can have a look inside this thing. Guess I can bring the zoom back out just a little bit and bring it back up so you can see kind of what I'm doing here. Yeah, I know it's real exciting. Yeah, it's already starting to see flop here. So it may just fall out on me here, so I gotta be careful. I should have left the screw down at the bottom. So I gotta kind of watch what I'm doing here. I definitely want this to fall out and mess that up. And this bezel, I'm not real sure what I'm going to do with this. I'll have to take this completely off and see what I can do to repair it, keep it from breaking anymore. Put some kind of JB weld or something, I'm not sure just yet, in here where you can't see it, kind of hold it and then lightly sand this down, repaint this or something. But we'll see. But yeah, she's wanting to come out now. Keep my hand on that. And well, let's just get this rubber band off of here so I can get rid of this case. We'll have to pull this through the back. Alright, so, and should I pull on that there? I don't know. Okay. It's coming out. Let me get this case out of the way and I'll be back. Alright. Now I forgot to mention, I noticed something was rattling around this thing. And I found one thing. It's this screw right here. And it took me a minute looking at it, and I figured out what it is. It matches these screws here. There's one you can probably see over here and one up here. It goes right in here to hold this bezel on, and this one. Looking in there, I know you can't see it on camera, but a little stud that comes in for the screw to screw into is busted. So you have to just leave that out, or I don't know, when I take the bezel off, I'll see. So that was rolling around in there. And the lights, one of the lights was rolling around there like that. It'll just clip back in up there, just like that. So looking at it here, all right, let me reposition the camera. All right, looking at it here, we can see, where did my pointer go? What this is here is steel. So you can see rust is starting to come in here, but it's copper plated steel is what this is. And looking on the transformer, we can see all kinds of rust in here. It's coming off okay, but that can be cleaned up better. Got rust around in here, or corrosion. See off down in there. I think got the glare just wrong for you there. So this is being stored somewhere, not in the greatest environment. But other than that, I mean, I've seen way worse. So hopefully this thing will work okay. I don't know if it works or not. Of course, I didn't plug it up and try it because I know this thing is probably going to be. Somebody might have come here at one time and redone something, but probably full of 1951-year-old capacitors. So 70-year-old capacitors, so they'll have to go, and something like this, you know, like this here, I'll have to get rid of this, or I'll probably, you know, like I usually do, leave this for cosmetic look and for aesthetics. Underneath, I'll replace it with two capacitors. It's got two 10 microfarad capacitors in that little can here. So those will be really easy with modern equivalents. So there's no screws missing here. This is those two in the back here. Let's come down here. See, there's 4 screws here to take out, so we'll just take these out. And this is an RF shield. And there again, if this was something different, you want to keep these screws separate. But it's, as I can see, it's the same screws all the way around. I know a lot of stuff back in these days use the same screws. Nowadays they use 10 different screws and try to take something apart, or not screws at all. It's all snapped together plastic. So anyway, there's that. And then There's probably, yeah. Let's see, be careful how I set this thing. We've got 4 screws here, so we'll take them out. And I'm going to guess up here, before I pull this off, right here you see some places to adjust something. It's probably going to capacitors in there, little capacitors. And you got, well, that ain't even locked. But you back this off, unscrew this little nut here, adjust it where you want it, and then tighten this back down so it holds it. And this will be 1, 2, 3, 4, 5. There's 5 there. Is that right? 1, 2, 3, 4, 5. So there's 6 knob positions. But I've not looked at the schematic. But anyway, this will probably be to adjust so that it tracks the face of the unit. Like if you've got it aimed at 600 kilohertz or 1,000, you know, say you got it aimed at 1 megahertz, 1,000, you know, kilohertz, but you're not, you know, outputting it, you're off a little bit, you can adjust these to line that up. Is what I'm thinking that's what those are. I've been into a lot of these things. I never had one of these apart before, but I'm pretty sure that's probably what that is. Okay, so this should come off now. Well, come on now. Oh, I missed a screw. I was thinking 4 and 4, but nope. This one's got another one right there. Okay, there we go. Yeah. So you can see this rust coming through here. If this was aluminum or actual copper, it wouldn't be rusty like that. It'd be, you know, a green tinge or something, but it wouldn't look like that. Put that to the side over here. And let me try to get this and reposition the camera so we can look inside of it. And I'll be right back. Okay. You look over here, you'll see those capacitors I was talking about. Yep, there they are. And here's your coils for each different band. You go to the capacitors. I don't know if I like this angle, but it'll be good for now. This here is going across the line cord here. That's a 0.01. And it actually says oil. Find my spectacles here. It says oil capacitor, not foil with an F, but O-I-L, oil. It actually says oil capacitor. That'll definitely have to go because I don't want, you know, if this shorts out across this line, that's going to be bad. So this is a safety, you know, this is a filter is what this is for. And this here, this coil here, this choke, and this capacitor keeps RF from coming back down, you know, your line cord, and that really messed things up. You're trying to line up a radio or something. You got RF feeding back into it and coming in, you know, a different spot. So that's, you know, that's why this is here, and this capacitor and this coil, and that's why this is shielded up good. And this has even got its own shield here where the multiplier is. So that'll definitely have to be replaced. A safety capacitor there. And we got these 2 resistors here come off the power supply, and I know that because we didn't even go through that, but this is 6X5 and OD3. So these are, you know, regulator and the diodes for the power supply. That's, what was it, 8, 10? 10 watts, 6K resistor. And here's another resistor. This is a, you can see that. Let's see here. Yeah. That is a roundy type there, so we have to definitely check that. Especially for something like this. You know, some things you can test up and it's like, it's off a little bit, but yeah, that's okay. But that's the reason, I always push, I know some people like, I want to reform my capacitors and save them and whatever. And of course, a lot of that reforming capacitor stuff is just old stuff from years ago that still keeps being handed down when the capacitors was real expensive. Now capacitors cheap enough, change them out. And then of course, that's not counting the audio, guys. I know it does make a difference in sound. And that'd be, something different. Talk about in a different video. But for something like this, a piece of test equipment, as cheap as capacitors are, you want to get rid of all these. There's a poly type there. That's probably okay. But all these paper and these oil capacitors and stuff like that, and these electrolytics up here in the can, that's got to go. Well, there's one hiding back here above the band switch. That's another oil. Got to change them out. Got to get rid of them. And then, especially something like this, you want to go through and check all these resistors. And if they're anywhere out, and anywhere close to being out too far. Like a lot of these will be, like this is a 20% right here. Okay, if it's out 10%, I'm going to change it. Probably. Things like that, because this is a piece of test equipment. You want to make it, as close as you can to work. To where it needs to be. It's not something that's, if it's off a little bit, it ain't going to matter. But test equipment, you want to keep it as accurate and as close as you can be, for what it is. There's a lot better ones they made back then. It was a lot more accurate than one of these. This is an Eico kit. But for what it is, make it as good as you can for what you have. Don't say, this is a cheapo kit, whatever. Hey, these things work pretty good, some of this old stuff. And it's better than nothing, better than having nothing on your bench. If you want, you're a hobbyist and you want to get something to restore and use, you may not have the budget to go out and buy a $3,000 or $4,000, RF signal generator. So why not use one of these? And most of the stuff you're going to do as a hobbyist, it'll be good enough. You don't need all the accuracy and all that from the high dollar stuff. Or start off with something like this and slowly, buy, more expensive, stuff. But anyway, so I'm going to check all the capacitors in there. And we can actually just look at some of them right now, maybe. Let's see. I'll set that right there. And maybe that'll work. So let's look at this one back here. I'm going to try to get this where you can see this, and you may not see me. Well, this you will, but that's okay. This back here I was looking at is a brown, black, red, so that will be 1K. And there's no other band, so it's 20%. I'm on. Now, I can't get a good connection on that. 1.175. That ain't bad. And if you're new to this type of stuff, you're used to working on more solid state things and whatever, you're like, how you can't check a resistor in circuit? Well, you can. Sometimes you can't, but there's a lot of times you can on these, because tubes are really high impedance. Just by nature they are. So you can 99% of the time, maybe I should say 90% of the time, you can test resistors in circuit. It depends on, like, if this is a resistor here, you want to cross this coil, you couldn't do that, because this is going to show a dead short. But in this case, you can. Let's see if I can get a good connection on this 6K here. 5.7. Plus or minus 20%. Well, that's within tolerance, so we'll see how that goes. That might be all right. Let's see. Like this. What else we got in here? Right here we got a brown, black, green, so that's 1 meg. Let's see what that's showing. 0.927. 20%, that's within tolerance. Now these all over here are, well, no, they're not either. That one I just checked is Allen Bradley style, but this one down here is a roundy. Brown, black, orange. That'd be 10K. 16K. Let's see what I'm across here. See, you still got to look. That's going. That one might be reading wrong. Let's see. Let's pull this tube out here. That's another thing about this. Well, that tube is not budging. Don't want to break. Well, you know what? This tube may be. Wow. This is an octal tube. You just got to rock them real slightly back and forth and pull up on them. Or pull away from the socket. Look at that. Here's a couple things with this tube. You see all that? That's definitely got to be clean, that corrosion. And you see this white in it? Listen to that. When you take it, that's down next to the microphone. Yeah, that one's gone. But you can see this white. When you see white on a glass of a tube like this, silver stuff's fine. Or, you know, you see a dark gray spot sometimes on the side. You know, that's getter compound, that's fine. But you see that white, this thing has sucked air in it. It's gone. It's time to replace it. So that's going to be replaced anyway, and that's a 6SL7. So that'll have to be replaced. But I wanted to pull that out just to see. Let's see here. I get this back. You can see it maybe. And we're still in 16K. Yeah, that's way off. Those roundies are bad to get water ingression. And this has been in a damp environment. They'll draw water in them and they'll really read off. So that'll have to be replaced. Here is a yellow, violet, brown. So that's 470 ohms. 550 ohms. Yeah, that'll have to be replaced, in my opinion. Blue, gray, orange. Oh, let's see if that's reading 68K. 67K. That's not too bad. That's Allen Bradley style. But, I mean, you see there's not a whole lot to this. So we pretty much went through all the resistors. 1, 2, 3, 4, 5, 6, 7. I think I went through all the resistors in this thing. Not counting the potentiometers, of course, but yeah. So, and you can see all this corrosion here, this rust coming through. Because this is, like I said, this is steel. This chassis part here made out of steel. It's got a copper coating on it. Okay, let me move this here. Let's see if I can get a peek in here. Let's see what we got. Real quick here, and I'll end this video up here and we'll. Okay. Yeah. What is that? Yeah, some kind of something fell off in there. It needs to be taken out. Yeah, there's your multiplier resistors. Let me get where you can see those. Yeah, you can see them good enough there. Let's check this one here and see what it's reading. Well, I'll just look at the meter myself here. Well, am I on the right thing? It's supposed to be 100 ohms. That's reading 1K. Maybe I'm on the wrong. 1.3K. What? Yeah, I'll have to get in there better and check that out. So. Oh, wait. Okay. Never mind. I was across the 1K. So there it is. There's the unit taken apart. We went through it and looked at it. So I'm going to replace the safety capacitor here, change out the paper capacitors, change out the resistors are out of tolerance, and we'll come back in part 2 and look at it. I have to check these tubes and change them out. Check all these tubes now, maybe. And it's got a 6C4 oscillator. And come back to it, and we will look at some more of it in part 2 when this has been redone here. I've had people ask me, they'll say, well, why don't you just make it all one big video? You know, instead of part 1, part 2, part 3. Well, from what I found, even from my personal experience, you sit down, you see a video pop up on YouTube, and you look at it, it says an hour long, an hour and a half long. You're like, I kind of want to watch that, but I don't know, it's so long. You know, end of the day, I just want to watch something, whatever. These kind of get long, you know, at 30 minutes or so, but to me, but I don't want to break them down into 10 videos. You know, it's like 10 minutes a piece or something or whatever. That's a little bit silly to me. So that's why I break these up. So in case you're wondering about that, like why you break them up and whatever, so that's why. It just seems like it's take it in little bites, or a little bit bigger bites, instead of trying to swallow the whole thing at one time. And you can watch one at one point, and then you can another time watch another one, and so on and so forth. So anyway, let me get all this stuff done, get everything done with all that, and we'll come back and go through the alignment on it and look at the schematic a little bit and see if I can find a schematic on it. I'm pretty sure I can. Eicos are usually easy to find schematics for. And we'll see what we can do with this thing, see how accurate it is, and see how it works. So until the next video, this is Michael, KE4EST 73.